Hey guys, in this video we're going to be looking at how to find the equation of a line perpendicular to a given line segment that runs through its midpoint. So this is certainly on its way to the higher end of GCSE maths, higher GCSE maths. To be honest, I would say it's right up there at the top. That doesn't make it impossible though. This is a classic case of putting together smaller skills to attack a bigger single problem. So the skills you're going to want to be really happy with here before we get going: finding the gradient of a straight line, finding the midpoint of a straight line, knowing how to find equations of straight lines, and also knowledge of perpendicular lines. So when it comes to the perpendicular lines, remember that if two lines are perpendicular, it means that they're meeting at right angles. In terms of their gradients, it means their gradients multiply together to give us -1. So if any of what I just mentioned sounds tricky at all, or you want a refresher, go back, check out my videos on each of the separate topics, make sure you're proper happy before we come back to this video, put them all together and see how we attack this type of question. So if you are happy, let's get cracking. Okay, so question 1. We've got point A that has coordinates 2, 8 and point B that has coordinates 4, 12. Now our job here is to find the equation of the line that runs perpendicular to AB and also runs through the midpoint of AB. So we need to find two things before we can go about finding the equation of this line. We need to find the midpoint of AB and we also need to find the gradient. So let's first of all find the midpoint. Now remember, the midpoint coordinates are the average of the two coordinates we're given. So to find the x coordinate of the midpoint, we're going to do 2 plus 4 divided by 2. And to find the y coordinate of the midpoint, we're going to do 8 plus 12 divided by 2. So that will give us our midpoint coordinates of, well, 2 plus 4 is 6. Divided by 2 is 3, and then 8 plus 12 is 20, divided by 2 is 10. So the coordinates here of our midpoint of AB are 3, 10. Now instead of us having to look at my horrible writing a lot, I've gone ahead and written down the midpoint nice and neatly. So we found the midpoint of our line AB. Now we need to find the gradient. Now we're going to call the gradient little m with a 1 after it. So m1 is going to be the gradient of our given line segment here, AB. We're going to call the gradient of our perpendicular line m2. So don't mistake the m for the midpoint, which is a capital, with the m's for the gradient. Okay, so to find gradients, remember that's the difference in our y values. So here, 12 take away 8, divided by the difference in our x values. So 4 take away 2. So 12 take away 8 on top gives us 4, and on the bottom 4 take away 2 gives us 2. So then finally we get our gradient of AB. 4 divided by 2 is 2. Okay, so now we know the two things that we need to know about the line segment. The midpoint has coordinates 3, 10, and the gradient is 2. So now we've got all the ingredients we need to find the equation of the perpendicular line. So let's first of all find the gradient. Now remember, if two lines are perpendicular, their gradients multiply together to give us -1. So we could write down m1 times m2 equals -1. Now we know that m1 is 2, so we got 2 lots of m2 is -1. So the gradient m2, if we divide by 2, m2 then is -1/2. So the gradient of our perpendicular line is -1/2. Now we can shove that into y equals mx plus c, Now we know that y minus 1/2 x plus c is the start of our perpendicular line. Now we need to work out the value of c, the y-intercept. Now we do that by substituting in the values of the coordinates we know the line passes through. So remember, the line is passing through the midpoint of AB. Now the midpoint coordinates were 3, 10. So when x is 3, y is equal to 10. So if we substitute that into y equals minus 1/2 x plus c, then we're going to get 10 is equal to, now minus 1/2 times 3 is minus 3/2 plus c. Now we need to get c on its own. Ideally we want the left hand side to be in terms of halves here. So if we have one whole pizza, we would have 2 halves for pizza. If we've got 10 whole pizzas, we've got 20 halves of a pizza. So on the left we've got 20 halves is equal to minus 3/2 plus c. So if we then add the 3 halves, then on the left hand side we're going to get 23 halves, and that's our value of c. So now we've got the equation of our perpendicular line. We now know y is equal to minus 1/2 x plus 23 halves. That is the equation of the line perpendicular to AB that passes through its midpoint. Jobs are good 'em. Okay, example 2, so we've got exactly the same sort of question here. Point A has coordinates 2, minus 1, and point B has coordinates minus 10, 5. Find the equation of the line perpendicular to AB that passes through its midpoint. So again, we're playing exactly the same game as the last question. Let's first of all find the midpoint of AB. So, again, the midpoint is the average of the coordinates. So, if we add the x values, we've got 2, add minus 10, which is going to give us 2 minus 10, and that's over 2. And then for the y coordinates, we'll minus 1, add 5, which is going to give us minus 1, add 5, over 2. So then, M has coordinates, well, 2 minus 10 over 2. 2 minus 10 is minus 8. Divide that by 2, we get minus 4. And then for the y coordinate, minus 1 add 5 is 4. Divide that by 2, we're going to get 2. So the coordinates for our midpoint are minus 4, 2. Jobs are good. Okay, so now we also need to find the gradient of the line that connects A and B. So again, we're going to call that M1 because it's the gradient of our first line. Now here we're going to do 5 minus 1, the difference in y, over minus 10 minus 2. So 5 minus 1 is 5 plus 1, which is 6. Minus 10 minus 2 is minus 12. Now 6 divided by 12 is a half. We've got a minus on the bottom, so that's going to give us minus a half. So M1, the gradient of AB here is minus 1/2. Okay, so now we've got the ingredients that we need to find our perpendicular line that passes through the midpoint. We've got the midpoint, we've got the gradient of our first line. Now we can work out everything we want to about the perpendicular line. So let's first of all work out its gradient. So here we know then the gradient of AB is minus 1/2. So the gradient M2 of Mr. Perpendicular line is minus 1 divided by minus 1/2. Now when you divide by a fraction, it flips around and becomes a multiplication. So that's going to be minus 1 times minus 2, over 1. If you like, you don't need to write the over 1. 2 divided by 1 is 2. But if it helps to keep it as a fraction, then please do. So then minus 1 times minus 2 is 2. So the gradient of Mr. Perpendicular line is positive 2. So if we stick that into y equals mx plus c, we know then that our perpendicular line is something to do with y equals 2x plus c. Now we just need to find the coordinates of c. So we know a coordinate, or we know a pair of coordinates that this line has to pass through. It has to pass through the point M, which is the midpoint of AB. So point M has coordinates x equals minus 4 and y equals 2. So if we shove that into y equals 2x plus c, we're going to get 2 is equal to 2 times minus 4, which is minus 8 plus c. Then if we add that 8, we would get c is equal to 10. So we've got the equation of our perpendicular line much nicer one this time. We've got y is equal to 2x plus 10. Jobs are good in. Okay, so the last one of these beauties for this video. If you're feeling happy, pause the video, have a go, try yourself. If not, let's do it together. So this job is worded a little bit differently than the last ones, but we're playing exactly the same game. So find the equation of the perpendicular bisector of the line joining points 4, 3 and 8, 11. So remember, a perpendicular bisector is a line cutting a line segment in half at right angles. So it's a line cutting a line segment through the midpoint, exactly the same as the last two questions. So let's play the game exactly the same as we've played the others. Let's find the midpoint first. So for that, we're going to do 4 plus 8 divided by 2 for the x coordinate, and for the y coordinate 3 plus 11 divided by 2. So that then tells us the coordinates of our midpoint are 4 plus 8 is 12, divided by 2 is 6, and 3 plus 11 is 14, divide that by 2, and we are going to get 7. So we know the coordinates of the midpoint of the line connecting these 2 points together is 6, 7. Okay, so now we need to find the gradient of the line connecting these 2 points. Again, let's call it M1. So the gradient, difference in y, so let's do 11, take away 3, divided by the difference in x, 8, take away 4. So 11 take away 3 is 8, 8 take away 4 is 4, then 8 divided by 4 on a good day is 2. So the gradient, M1, the gradient of the line connecting these 2 points together is 2. So now we've got both of the ingredients that we need to be able to find the equation of our perpendicular bisector. So let's first of all find this gradient. So the gradient M2 is minus 1 divided by M1, so it's going to be minus 1/2. That tells us our perpendicular bisector is something to do with y equals minus 1/2 x plus c. So for our final step, we need to find the value of c, which we do by substituting in the coordinates of our midpoint. So those are telling us that when x is equal to 6, y is equal to 7. So we're going to get 7 is equal to minus 1/2 times 6 will give us minus 3 plus c. Then if we add the 3, that's going to tell us c is equal to 10. So the equation of our perpendicular bisector here y is equal to minus 1/2 x plus 10. Jobs are good. Okay guys, I hope you've had as much fun as I have. Hope it's helped. Was this video helpful? If so, don't forget to hit the thumbs up button and leave me a comment letting me know how you get on. Also, don't forget to subscribe to the channel so you never miss any videos. For any further information, you can find me on Facebook or Twitter. Search for Maths with Melv. Cheers guys.